Welcome to Revolution Games Academy. In today's video, we'll be covering the basics of creating rope and chain physics in Unity. This tutorial will guide you through setting up a simple and functional rope or chain system that you can use in your projects. Whether it's for a game or a simulation, we'll keep it straightforward and easy to follow. Let's get started. First, select a 2D object sprite to represent a single segment of the chain and add a rigid body 2D component to enable physics-based movement. Add a collider 2D to allow interactions with other objects in the scene. Here, as my object is a capsule shape, I will use Capsule Collider. Let's change the color for more viewability of Capsule Collider in the scene. In most cases, Colliders matches the sprite renderer. If not, adjust the size of the collider to match the scale of a segment in your chain. Now let's add a hinge joint 2D. This key component acts as the connector connecting each segment in the chain. The hinge joint allows the segments to rotate around a fixed anchor point, simulating the movement of a chain. Let me break it down further. Anchor is the point on the object where the joint attaches, and it's also the point around which the object will rotate. I'll demonstrate this in action. When I enter play mode and use the player ball to hit the segment, you'll notice that it doesn't swing but instead rotates around the anchor point. This happens because the anchor, which serves as the pivotal point for rotation, is currently positioned at the center. In real life, an object doesn't swing when it's hanging from the center. However, as soon as I adjust the anchor's value and move it away from the center, the segment begins to swing. Limits. These are used to restrict the rotation range, preventing the chain links from spinning uncontrollably and ensuring the chain behaves realistically. We will play with these properties of hinge joint, which are the ones mainly be used for tweaking chains, later on this video. Now, let's return to building our chain. As we want the chain to behave like a real chain, so the anchor of each segment should be positioned at the top of the segment. This allows the chain to swing and create the desired chain reaction as the segments move. By placing the anchor at the top, the segments will rotate around that point when force is applied, letting them interact naturally in the chain. You can use the Edit Joint button to move the anchor position to the top. As you do this, you'll notice that the anchor property in the component's value updates, which means you can also adjust the anchor position directly using these values. Organize the chain by creating an empty parent game object in the scene. This will serve as the container for all the segments. Next, start duplicating the segments as many times as you need to form your chain. However, be practical with how many segments you create. More segments will add more complexity to the physics calculations. For this tutorial, I have created 6 segments in total, but feel free to adjust this number depending on your needs. Next, we need to link the segments together. For each segment, drag the adjacent segment into the connected rigid body property of the hinge joint 2D to link its rigid body. This step informs Unity that these segments are physically connected, ensuring that when one segment is affected by physics, the next one follows suit. Start this process from the bottom segment and work your way upward. At the end, the top segment will not have a connected rigid body. For this, create an empty game object and name it Anchor. This object will act as the holder for the chain. Add a hinge joint to the anchor. Finally, drag the rigid body of the anchor into the connected rigid body property of the top segment's hinge joint. This ensures the top segment is linked to the anchor and swings at the desired position without issues. Since this anchor is simply for holding the chain, we need to set Auto Configure Connected Anchor to false, as we don't want Unity to automatically configure its position, which will in turn make the chain consider it as a segment, creating empty gap between anchor and segment. One important thing to remember, the anchor and the first segment must be positioned in the same spot. If they're not aligned, moving the anchor will cause the first segment to swing at a distance, creating a noticeable gap due to the connected rigid body. To avoid this, ensure both are perfectly aligned before continuing. Now, if you look closely, you'll see that while the positions of the objects seem to match, the anchor's position is slightly off. Let's play the scene and observe what happens when we move the anchor. See how the gap appears when I move the anchor? This is why it's crucial to ensure proper alignment between the anchor and the first segment. This method of creating chain physics in a 2D environment is more functional and easier to implement compared to other methods, such as using bone. If you're interested in learning about the bone-based method and also creating a 3D rope process is similar to what we followed for the 2D chain with a few differences, let me know in the comments.